Here we're going to talk about the addition rule, and before that we need to talk about definition. So first definition, two events A and B are mutually exclusive when events A and B cannot occur at the same time. It's impossible for one to happen and the other one doesn't. So in a picture, what does this look like? So if this is my sample space, then if this is event A, over here is event B. They don't overlap, meaning it cannot occur at the same time. All right, if I fall into A, then I'm not into B. Okay, and if I'm in B, then there's no way I can fall into A. They're mutually exclusive. So mutually exclusive events. Can I roll a 3 and roll a 4 at the same time? These outcomes cannot occur at the same time. Therefore, they are mutually exclusive. Now, can you roll a 3 and then roll a 4? Yes. But what's the difference between this scenario and this scenario? The first scenario is saying, in one time, at the same time, can I roll a 3 and roll a 4? The second scenario says I roll a 3, that's at one moment, and then a later moment, can I roll a 4? Yes, that's possible. That's two events. Okay, that's not what we're describing here. With mutually exclusive, this is different than independent. Okay, so in fact, it's so different that if two things are independent, okay, so I'm sorry, if two things are mutually exclusive, then that means that they are totally dependent on each other, okay? Meaning if one thing happens, then there's absolutely no way that the other thing will happen. And that's total dependence, not independence, okay? So a lot of students get independence and mutually exclusive confused with each other. It couldn't be further from the opposite. So here's another example. Randomly select a male student and randomly select a nursing major. Are those mutually exclusive events? Well, a student can be male and a nursing student, believe it or not. Therefore, they are not mutually exclusive. Okay? Very clearly, a lot of people are male nurses, okay? So what does that look like? If this is all the males and these are all the nursing majors, the overlap here, this is a scenario where they overlap, okay? Therefore, it's clearly not mutually exclusive, okay? So what are we saying here? If the probability of A and B is equal to 0, okay? So the probability of A and B is equal to 0, meaning they don't overlap. That's what this means here. Okay, they don't overlap. It's equal to 0. Then what does that mean? Then if A and B are mutually exclusive, then A occurs, then B cannot occur. Okay? They are totally dependent. This implies dependent. So mutually exclusive, then you are dependent. Okay, it's the exact opposite of independence. Now let's get on to the addition rule. Okay, so here's the addition rule. The addition rule is the probability of A or B. Okay, so the key word here is or. With the multiplication rule, the key word was and. With the conditional probability rule, the key word was given. So the probability of A or B. So this is equal to the probability of A. So if this is a set for A, this is, let me do this. So that's a set for A. This is a set for B. So the probability of A would be this area and this area. All right. So if I shaded it, it would be right here. And then plus the probability of B. The probability of B will be this area and this area. And so I would shade here. And then I would shade in here. But there's a problem. What's the problem? I accidentally counted this middle twice. So I need to get rid of the middle, the intersection. So I need to subtract out one of those check marks. Probability of A and B, subtract it out. So if I subtract that out, that check mark goes away. And now I've checked it, each area, probability of A or B, exactly the one number of times that I need to do. Okay? So this is if we have an overlap. Now there's a formula in your formula sheet, and it says the probability of A or B equals the probability of A plus the probability of B, and that's it. This is only true if I have a scenario where there's no overlap. So I have an A here and a B here. So that's only true if if A and B are mutually exclusive. Okay, so that's not always the case, though. It's not always mutually exclusive. So this rule always works. Why does this rule work? Well, say it was a sense is mutually exclusive. What's the overlap between A and B? That would just end up equaling 0 with this scenario here. And so that's where this part comes into play. Okay? So this formula right here works no matter what. All right, so this is the formula I want you to stick with. So we're gonna do an application of those, and I guess we'll just do it in this video. Why not? So roll a die, flip, and then do the probability. What's the probability that I roll a 4 or a 5? This is equal to the probability of rolling a 4 plus the probability of rolling a 5 minus the probability of rolling a 4 and a 5. Now, what's the probability of rolling a 4? So our die is 1, 2, 3, 4, 5, 6. There's only one 4, so it's 1 out of how many total? 6. There's only one 5, so that's 1 out of 6. Now, what's the probability of rolling a 4 and a 5 at the same time? Those are mutually exclusive events. I can't roll a 4 and a 5 at the same time, so there's no chance that I can do that. So my answer here is 2 out of 6, which is 1/3, or 0.333 if you got to do to 3 decimals. Okay? Now, the second question is a number that's less than 3 or an even number. So I'm going to call a number less than 3, I'm going to call that event A. And I'm going to call an even number being an event B. So what's the probability of A or B? This is equal to probability of A plus the probability of B minus the probability of A and B. Now, let's take our scenario that we had here. All right? With this first part, probability of A, this is a number that is less than 3. A number less than 3 is 1 and 2. Those are the only numbers that are less than 3. So that's 2 out of 6 that satisfy that right there. Now, B is an even number. So even numbers are 2, 4, and 6. So that's 3 out of 6. There's 3 of those that satisfy it. And then I subtract off, what's the chance that you're even and you're less than 3? Well, there's one number that is an even number and it's less than 3, and that number is 2. It's the only one, so that's 1 out of 6 that I have to subtract away. And when I do 2 plus 3 minus 1, what do I get? I get 4 out of 6 total, which is 2/3, or 0.667 in decimal form. Okay? This example here with a table, we've got a blood bank categorizes blood by given donors. So the blood types, so we have O, A, B, AB, and the total. We have positive, we have negative, and then we have the total for our RH factor. So there were 16 O positives, 3 O negatives, and 19 total O's. We have 14 A positives, 2 A negatives, 16 total A's. 4 B positives, 1 B negative, 5 total B's. 1 AB positive, 0 AB negative, and then 1 total. How many positives total did I have? Looks like 35. How many negatives total did I have? I think that's 6. And so 41 people total were sampled. First thing I want to do, I want to find the probability of selecting a donor that has a random type of O or A. So I'm going to say type O for the letter O and A for the letter A. So let's do this. What would this be? This would be probability of O or A equals the probability of O plus the probability of A minus the probability of O and A. So what does the probability of O equal to? So the probability of O, that's the total people who have an O factor. So O, blood type, is 19 out of how many total? 41. Okay, that was O. Now for A, there were 16. So plus 16 out of 41. And then probability that you're O and A. Well, you can't be O and A at the same time. So that's 0. There's no chance of that. And so what is this? It's 19 plus 16 gets me 35 out of 41. That's my probability. The addition rule, you add. Multiplication rule, you multiply. Or is the key word that tells us it's addition rule. Here, I look at this, I see it's the probability. Select a donor that's type B or negative. So to use a type B scenario, I'm going to use the letter B. Negative, I'm going to use the N letter. So I want to find the probability that I'm a type B or negative. This is equal to type B plus negative RH factor minus probability of being B and negative. So what is this equal to? So let me change this color. This is going to be type B is going to be, how many are there? There's 5, so it's 5 out of 41. Negative, how many negatives total are there? It looks like there's 6 negative total, so that's 6 out of 41. And then subtract, So negative people in type B who are both negative in type B. There's only one person that is negative in type B. So that's 1 out of 41. And so what does this equal? This is 10 out of 41. So 10 out of 41, let's see. That'd be 10 divided by 41, which is like 0.244. That's what it looks like. Roughly 244. And then if I did a decimal over here on the 35 over 41, I get 0.854. 854. All right, guys. So this is how you work that type of problem there with your table.